Hey everybody, so here is the solution to the gold problem, the one that I mentioned in the video yesterday, in terms of how to be able to kind of cope with this thing. So the essential question was, how do you figure out the mass of each brick of gold? So a couple of things on here. Number one, you know you're going to have to use the density equation. Density is mass divided by volume. And in this case, what we're looking for is mass. That's what we're going to try to figure out. We're given density. Density is right here, 19.32. And we need to figure out what volume is. And that's what we can use here to figure out what our volume of these particular blocks are. So the first thing we have to do is convert all of our inches to centimeters. Since, again, our units of volume are in cubic centimeters, can't have cubic inches and cubic centimeters talking to one another. They're not the same unit. So this is a tiny Wunderfraction. Yeah. So you would do 7 inches and convert, in this case, remember, cross down, inches are going to convert to centimeters. And in this case, because I gave you down at the bottom here the conversion factor to it, I know that 1 inch is equal to 2.54 centimeters. So in this particular case, grab my handy calculator out. 7 times 2.54 gives me a value of 17.78 centimeters. If I do the same thing for the other ones, 3.625 inches and 1.75 inches, and I convert each one of these to centimeters as well, 1 inch, 2.54 centimeters, 1 inch, 2.54 centimeters, I will get all three of my values for this. So 3.625 times 2.54 is 9.2075, and then 1.75, the bottom one, times 2.54 is a value of 4.445. So all of these are centimeters, and that gives me the size of one of these bricks of gold. One of these monsters over here is 17.78 centimeters long, 9.2 whatever centimeters wide, and about 4 centimeters tall. So if I take a look at this, I don't really have a good number of sig figs in here, simply because of all the different numbers that are given. My conversions here, I don't ever use conversions for it. My inches are kind of all over the place. I'm going to assume that this is 7.00. Let's cheat, and I'm going to make a call here. Let's call it 3 sig figs for this particular problem. 7 inches has 1 sig fig, but I'm sure it's exactly 7. I'm sure it's probably 7.00 something. So I don't know why they just put a 7. 3.625 has 4 sig figs, and 1.75 has 3 sig figs. Looking at my density over here has 4 sig figs as well. So going with 3 or 4 sig figs is good enough. So let's not freak out about it too much. Excuse me. Sorry, guys. So now the next part is I have to figure out my volume. Length times width times height, which in this case is going to end up being the product of 17.78. Actually, let's do 17.8. Sorry, 3 sig figs, 17.8 times 9.21 times, right? So this would be 9.21. This would be 17.8. Sorry, 3 sig figs. Try to make my notes on here correct. And this would be 4.4, and that would be 5 because 5 rounds up. So my volume again would be 17.8 times 9.21 times 4.45. 4.45. My handy calculator tells me that my answer to this is 729.5241 and change. So 3 sig figs would make this 729.5. The 5 is going to round it up, would make it 730 cubic centimeters. This actually has 3 sig figs to it because I put that little decimal place at the end. So 730 decimal place means exactly 730. So there's our cubic centimeters for that. So now, once I've got all this kind of stuff done, now it's kind of a matter of doing some calculations. Let me get rid of some of this stuff. Oops, sorry. Let me get rid of some of the, I'm using my pen wrong. Sorry, guys. I have a cool little graphic tablet kind of thing with a pen on it. I'm just not very good at using it yet, so my apologies. So what do we know? All right, so we've got our volume is 730, and we've got our density. So let's plug our numbers into that and figure out what we've got. So density equals 19.32. This is density equals mass divided by volume is what I'm working on. So I got the density from here. I've got my volume from here, 730 cubic centimeters. And then it's going to be mass is on the top. So this is centimeters cubed. This is grams. So algebra-wise, this is going to be 19.32 times 730 will give us our mass. So 19.32 times 730 gives us a mass of, wow, these are heavy, 14103.6 grams. Well, what does that mean? I don't know how heavy that is. So in terms of figuring out what that value would actually mean for us, well, first thing first, let's convert that to, since we're going to try to use this down here, I want to know how many pounds this thing is eventually. Let's convert it to kilograms first. So just as a reminder, there is 1,000 grams in every kilogram. So 1 let's give this to 3 sig figs, right? 1 I guess 1, yeah, 0, 0, right? This number right here is about 14,103. So this is about 14,100 grams. I want to convert that to kilograms. 1,000 grams is 1 kilogram. That's okay, sorry. So divide by 1,000, divide by 1,000, which is moving the decimal place over, 14.1 kilograms. And then if I want to know how many pounds that is, 14.1 kilograms, and I would convert that 2.1 kilograms equals 1 pound. So 14.1 divided by 2.1 gives me the value of 6.7, well, 16 or 6.72 pounds is how much each one of those things weighs. So there you go. There's the answer to the gold problem. It has a little bit of practice with using density, has a little bit of practice with using volume, and has a couple little versions of you to remember how to use the Wunderfraction. Yeah. Have a great day, you guys. See you later.